All right, we should be live. Yeah, let me just make sure my mic is on, but we should be good. So, first case we're going to be looking at today is an A2289 that was liquid damaged and the backlight flickers on it. Now, we're going to open it up and see what we find here. So, let me switch over to the overhead camera. I think our overhead camera is up and working. We shut off the microscope light and adjust this just a little bit. This camera has some like weird accelerometer thing in it that senses, so excuse the weirdness until we're done. Maybe it won't want to stay. Alright, we're gonna not worry about the overhead right now because as you see it's not having a good time. So anyway, we're gonna go back over here. We've got a few people in chat and Anel is saying he doesn't have any audio. I don't think that's true. I think that is not true at all. If anyone else more trustworthy can tell me if we have audio, that would be great. Yeah, I figured Anel is just being Anel. So anyway, continuing on, we're going to open this thing up and see what we have. Alright, so first thing I note, the battery has been disconnected. So that's actually a good thing. We're not going to give anyone a hard time for disconnecting their battery. So the battery is disconnected and I can see why we most likely have flickering backlight. And I see something else very, very concerning that makes me not want to even apply power or plug this battery back in until the liquid has been dealt with. So I'm going to go to my microscope and we are going to have a look here. So briefly, here's what scares daylights out of me is this right here. Come on, get in focus. That is our SSD 2v5 NAND regulator. Now, it looks like the regulator got saved. It does not look like too much liquid got under the regulator. Looks like it mainly just got around it, but I am not going to apply power until this area has been fluxed and cleaned thoroughly. Now, on to our backlight problem. This is our backlight circuit. It has corrosion. And our backlight MOSFET and fuse and everything is right here, and that looks great, doesn't it? It looks just amazing. Anyway, let's get this board out and let's get to work. I'm going to switch over to this view. Wish the overhead was working properly. I wonder, does this have some kind of a weird setting? Let's try this way. See if it's more stable this way. So excuse the oddness. Okay. It's like it has an accelerometer or something in it. Let's see if we can disable that. It's got to have some gimbal thing. Apply rotation data off. Okay. What about now? Aha. Okay, that was it. There we go. So we do not want to any rotation data because we don't care about that. We're working on a MacBook. We're not filming some waste of time Instagram video. Anyway, let's go ahead and get this board out. Focus looks okay. I'm going to switch over to my chat. And for whatever reason, OBS is saying that it's disconnecting. So if you notice it disconnects, let me know. Someone is telling me go to sleep, it's too late to be working. I disagree with that because I don't know where you are, but it is not late. Sleep is for the people that don't have complaining customers. Plus, I slept before I came in here for a couple hours, so makes it better. Long time no see, Bailey. How's things in Australia going? Any rolling blackouts? Not here. Midnight in Toronto. Yeah, it's not midnight here. So from what I see on this board, a majority of this does not look terrible. It looks like something that is easily going to be cleaned with some component replacement. So that's a good thing. It looks like this will be a savable device. So we are going to take off small screws now. I do all my T5s, and I'll do the T4s. And then lastly will be this one annoying screw that if you've ever worked on this device, you know exactly what I'm talking about. Board does not look super clean at all. Board does not look super clean. We'll go over that in a second. But yeah, the board is far from clean. I can assure you that. Do you do EFI and MDM unlocks? No, we do not. That's actually probably not the legalest thing to do, but we do not do them at all. So sorry, cannot help you there. We get a lot of people that ask us to, but we don't do it. And the reason being is most MDM and iCloud lock devices do not belong to the person that is asking for the unlock. Usually they are either company's property that they've gotten fired or quit and just kept the device. I mean, there's some that will be genuine, you know, people forgot, whatever. But a lot of them are simply not. A lot of them are, you know, stolen. And the thing is if a company or whatever presses charges on the employee, it can come back onto us and we can get in trouble legally for doing that as well. So, and furthermore, iCloud unlock. So this is something that really bothers me, that this is a thing in this industry. I'm going to switch over. I want to look at you guys when I say this. So I see in all the groups people offer iCloud unlocks and all this, and the fact of the matter is how most of these places are doing it is phishing scams. So they're sending out emails to somebody saying, oh, your iCloud account is compromised, you need to change your password. They enter in their old password, they enter in their email, it gets sent to the person, then they enter it in the device and it unlocks it. And it kind of makes me sick that that's this industry, and I want to be a part of that. I do not want to be in the same group of people that scams people. So no, we do not do that, and we'll never do iCloud unlocks. Genuine concern, but iCloud unlocks, no, absolutely not. And say what you will, I don't care. You know, I get people that tell me, oh, it's easy money to... Sorry. Everyone, is this stream going okay? Because I keep getting pop-ups saying that the stream is disconnected. So let me know if it's not okay. Anyway, we are ready to move on to the board. So, first off, let's have a look at our backlight driver area. So our backlight driver area is right here, and as you can see, it looks beautiful, it looks pristine, nothing wrong here at all. This looks incredible. So this seems weird, actually. My focus seems off. So that's our backlight driver. It looks pristine, it looks great. So I do not see any concerns whatsoever there. I do see some sign of liquid right there, sticky something. Carrying on, I'm just going to do an overview of the whole board just to make sure there's nothing hiding. It looks overall clean on the backside. Carrying on. Now the fun starts. This is our PP3v3G3 hot regulator. These guys, so for whatever reason, in this application, the 3v3 regulator here almost never fails. The SSD regulator does fail. I don't know why it's the same chip, but you know, that's just how it goes. So these components around here, I don't think the regulator needs to be replaced. I think that'll be fine with flux. I do want to replace those capacitors, this resistor, these guys here. This should just be able to be cleaned. And then the capacitors that look nasty, I will replace here. And then the backlight MOSFET, these resistors right here, and all this stuff should go. Flux around here and capacitor replacement here. This should be good to go. Anyway, let's go ahead and get going. So let's start. I am going to start now. I'm working near a connector, so I'm going to use some lower temperature because I do not want to melt this. I'm going to go around 260, and that should minimize melting on the connector. I'm going to get some Amtech NC559V3, and we are just going to dump a ton of flux on here because my mic's still working. Yeah. All right, let me get the ultrasonic heater started. And we're just going to flood this area with flux, going in the ultrasonic after. Way more than you really need, but we're just going to let the solvents in the flux take care of all that nasty corrosion for us while we preheat the area. We're only at 260 degrees, so it's going to take considerably longer to remove some of these components. But I'd rather have this than ruin our connectors. Notice how I'm working right near this connector and it is not fine, it's not melting or anything like that. I guess very slightly, but nothing significant. These guys like to short, so I'm not taking any chances with these. There's that. Let's go ahead, put more flux down. Start getting these joints all rejuvenated and nice and clean and healthy. Our connector did get a little melty, but not terrible. I mean, it would have been way worse if we used high heat. It would have destroyed the connector. Okay. Get some fresh solder in here. I should really start using my fume extractor. Just kind of clean this up my iron, then I'll wick in a second. I'll wick these big pads anyway. Oh, actually these look good. I don't think I need to. Yeah, these... These caps should just go away right there. These are just for EMI reasons. They're really not important. I just got a comment today saying, oh, well, the engineers wouldn't put these on the board if they're not important. Well, that's not always the case. I mean, yeah. A lot of times little capacitors like that are not a concern to leave off. And I've went over this 1,000 times, but people won't do it. But I'll put these back on for the sake of the video. But yeah, they're really not too important nor critical or needed by any means. And that looks good. Let's go grab a donor. I'm going to rebuild the 3v3 circuit first, and then we'll work on the rest. So, what does the wick do? The wick removes the solder. So let me just show you to demonstrate. So wick, this is what solder wick is. See how we have solder on these pads? Our solder wick, which is this copper braid type stuff. Let me get a little bigger piece. The solder wick actually pulls all of that out and away. So it pulls that solder out and away. Okay, this is our solder wick, right? It cleans the pad and it removes the solder from the pad like that, okay? So that's the purpose of solder wick, is it's to remove the old solder. And for the most part, I mean, it's... You will have times you really need it, and there's times like this where just putting fresh solder over the pad is just fine. So then once the solder's gone, we need to put fresh. So I'll just drag my iron around here and put fresh solder wick on all of these. Just like so. That is what solder wick does. This microscope looks weird. Hang on, I gotta fix this. This looks quite odd. It's like... Aha, that's why. Okay. Bear with me for 1 second. That's why it was cut off. That's much better. That's more in line with what I see. I was wondering why it was super zoomed in. It was really odd. Okay. Back to our 3v3. So let's grab a donor board. Let's grab a donor board that does not have a decimated 3v3 circuit from liquid damage. The struggle to find one. Donor boards must run and hide when they see me online trying to buy something. Here's one, because these boards all have they're just scavenged. Only put caps back on MacBooks. I'm still scared. Yeah, it depends on the cap. Yeah, I really should use the fume extractor. I agree. It's been a few months where I haven't used it. I really, really should. I don't like the looks of this cap. Don't you run away. I got you, little capacitor. You're not gonna run away from me. You really want to run away, don't you? Sneak you over. Come on. I really don't want to have to replace that keyboard backlight connector. That's why I'm using such a low temperature. This would be a lot easier if I was using my normal 430, 120. We're out of frame. No, we're good. Thought we might have been out of frame for a second, but we're not. There's another one coming in. And one more capacitor. Alright, so that is our 3v3 circuit rebuilt. Now, backlight. Let the board cool for just a second. Alright, backlight capacitors. These little guys love to short out. Mainly for no reason. They're usually fine after liquid. It's usually very random that they just short. They get cracks in them actually. I know that's not soldered. Just in case someone wants to comment that it's not soldered, I know. I'm just setting it down. It's gonna be soldered in a second. Do them in groups of 2, I think. 3 more. Let me get these little guys first, I think. Briz, your secret is heat and flux. Caps, they just pull themselves right into place. So as long as you have flux and as long as you have heat. Briz, what flux are you using? Are you using like some junk from Mobile Centrics? Or not just from Mobile Centrics, but some off-brand flux? Because if you don't have a good quality flux, I don't trust any fluxes that come out of China, honestly. So if you're using a flux that comes out of China, switch using it. That's probably what your issue is. So use real Amtech stuff. Amtech or MG Chemicals. I don't like Chip Quick. And anything off-brand, sorry. Looks like we're going to have to grab another donor because we are out of capacitors on this. I have one more, but I will need one replacement capacitor. Okay. So let's grab another donor that has our capacitor that we need on there. Just one. Your arm is healing from a puppy attack. Is that one of your dogs? And 70 pounds does not seem like he's still a puppy. Here's our backlight MOSFET too, that I'm going to replace that. Just because flickering backlight, I don't want to take any chances. Okay. So one thing I've really been on the fence of with YouTube is I'm considering disabling comments. So you see a lot of other companies, you know, on the internet, professional companies, they disable their comments on their social media, and it's for good reason. I mean, normally people, well, I shouldn't say normally, but there's so many people that think that they know best, and they don't know best, and they tend to put their 2 cents in. And it can actually be damaging because if a customer sees that, they may second guess over an opinion of somebody that is totally incorrect. And I sort of feel like that may be the better route to, not on live streams, not live chat, but comments on YouTube videos. That may be a better route than just leaving it on there. But I mean, the hide user on channel button is very useful for that reason, but it may be a better option just to get rid of comments altogether. Especially since we're working on growth, and yeah, like with the problem when we released Carbon Black, there's people that commented, and that led to more comments, people reading that and seeing that, and yeah, that's just a headache to deal with people like that. So I think going forward, disabling comments on pre-recorded videos is a good option. But then I think of the other way. It's like, what if someone needs something answered or help? But, I don't know. Ultimately, people are going to be loud, and that's just something that comes with having a YouTube channel. And we are around 100 subscribers from 10,000, so that is going to be a very nice accomplishment very soon here. So I look forward to that. And another very big announcement is coming up as well. So, yeah, things are going well. All right, so we took care of our backlight circuit. Well, not all of our backlight circuit. We still have this area. Now, this area, again, I'm just going to flood it with flux. I'm still working at our 260 temperature. I want to up it a little bit. Especially, I just want to flood this area with flux around the 2V5 regulator, because our 2V5 regulator is... And based on the history of this, I am not applying power to this until it has been ultrasonically cleaned, because we do not want to run power through something that can damage our NANDs, and even flux. This is why it bothers me. I mean, okay, light flux residue is fine to leave on boards. Oh, we gotta reball this chip now. It's alright, it's for the better. I'd rather reball that than chance it. I know this chip is fine because the device turns on, so we saved it. And these guys are kind of hard to get, so I'd rather not replace it unless I have to. My criteria to replace this chip would be as if there was any pads or balls that were degraded, and they were not. It was just corrosion around them. There does not look to be any damage of the solder joints, and in that case, it probably did not damage the chip electrically. So we should be okay. That's why it's important to, the minute you liquid damage your device, shut it off and stop using it. Bring it to a repair shop, unless you know how to fix it yourself, and fix it yourself. Do not put it in rice. That is a waste of time, and that does not do anything. Rice literally does not do anything to a device, so don't try to. I mean, if you are the kind of person that wants to dry out the device and put it in rice, here's what you can do. Go to the hardware store, get a little electronics toolkit. They sell them at Lowe's or Home Depot. Unscrew the bottom cover, unplug the battery. Unplug the battery, leave it off for 72 hours. If you want to do something before going to a repair shop, you can do that, and chances are, well, not chances are, but you will improve your chances of the device working after it dries fully. You leave the battery plugged in, you put it in rice, electricity is still flowing through the board, and the board will fail and be damaged. Okay, that looks pretty clean. It's going to Q-tip and acetone that and clean that up. Nice and clean. And now I have flux on my hands. I hate the feeling of flux on my hands. So I'm going to grab a little alcohol and wipe my hands off. It's just so sticky and gross, and it's not really harmful, but it's not nice to have on your hands for sure. Okay. Back to our board. And you can see the way this board looks. I mean, there's flux everywhere. I'm not going to apply power on this until it's ultrasonic. It probably won't even turn on because of the flux all over it. So we'll ultrasonic it, and then we'll move on to our next case. Then once this one is dry and ready, we'll come back to it. Get all my components around the chip done. The capacitor. Another capacitor. We have another capacitor. We have two more capacitors. And done. Let's go ahead and get our chip reballed. First off, I need to clean this bench off because, as you can see, it is not clean. It is full of flux, and it's very gross. And there's flux literally running down this board. Look at that. Can't see it. You missed it. Oh well. The board definitely needs an ultrasonic, but I'd rather have flux than corrosion because at least the flux is working to clean the board and clean all those nasty impurities and the corrosion off of it. Then it gets a nice clean bath, and then we're good to go. That bench is a scam, says Peter. What? Why is my bench a scam? Explain that. What's wrong with my bench? Sounds like you've been talking to Caleb a lot as well. That's something Caleb would say. Alright, Reball chip first or this? This is bothering me. I'll take care of this first. I know these stickers are melting. That's fine. We're going to remove them anyway. They're just cosmetic. And the board will look nice and clean when we're done. It's off. 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 There. That needs to be cleaned now. Yeah, we'll take these off right before we ultrasonic it. I mean, these come right off usually. All we really have to do is get an X-Acto knife and like this. These are just purely cosmetic. Just like that. It's off. I'll proceed to take this one off too, just because the smell bothers me when these are cooking. Just like that. We're done. Stickers are off. It's kind of hard to get in here, honestly, with the two. I do want to wick this area so because of how decimated it was. So I'm kind of just putting leaded solder down to help me. And now I'll get my wick and clean that up. So, and now we will put fresh solder in here. Backlight MOSFET pads. I think this is my favorite soldering iron tip right here, and I think this is starting to degrade because it does. I really like this tip. And it doesn't want to accept solder very well. Oh, that's why I have it on 840, not 740. So it's oxidized. That's why. There, now that should be better. Much better. Look at that. So much better. Alright, let's start transferring our new stuff on. First things first, I'll do the fuse, I guess. And just work my way back. It's not going to look pretty the first line around. We're just tacking it down. Now we can add more flux. Make it look pretty again. Good there. We have one last cap. I really am on the fence of turning this on. After ultrasonic, just because it eliminates a variable. I mean, we'll know if it doesn't work. But also, all this flux residue is not good. So, yeah, I don't think I'm going to. Alright, there's that. Does our CD3217 need any attention? It does. Okay. Give it a little reflow, and these two guys at the end need to go. Whoa. On this donor board, something just went on fire when I put the heat on it. There was a little piece of debris or something, and it literally just went into flames. Okay, we're good there. Now it's time to reball our little chip here. This, that'd be alright. Yeah, I don't want to turn this on. There's so much flux all over it. It probably won't turn on, and if it does, I don't want to risk damaging anything. So, yeah, we're not going to turn that on until it has its bath. We'll give this one 3 minutes aside. Spray it down with isopropyl alcohol first, then distilled water, and then it dries. It's amazing how clean these boards come out of the ultrasonic. Huh, where did my little chip go? Did that run away? That means I'm gonna have to find another one. Yeah, I had that on my bench and it ran away. Oh well. We'll replace it. We'll find another one. Hopefully I have another one here. Sure I do somewhere. Maybe that's a better idea anyway. Maybe that's the universe telling me this chip was bad, and if you put it on, you're going to ruin the SSD. Alright. Yeah, these TPS 6, whatever they are, let's see if they're still in stock. I need to order more. They've been out of stock, and you haven't been able to get them. So let's see if I can even get these guys anymore. Or if Apple said like, hey, we know these chips are dying. Texas Instruments, stop making them, or stop selling them to people. Okay, TPS, what is this? It is a TPS 62180. 62180. TI, DigiKey. In stock, 0. They have an evaluation board for the chip, but they don't have the chip. Can I buy it from TI direct? $62180. Available in 3,000 reels, or 3,000 pieces in a reel. What about Mauser? If not, I'll have... Okay, while that web page is loading, taking a long time for some reason, let me find another one. Gotta have one floating around here somewhere. Okay, Mauser. They have 7,000 on order. What's the delivery date? Yeah, that's expected May 15th of 2023. And August of 2023. August of 2023. That's a whole year away. Lovely. It's alright. I know there's one of these hiding on a board somewhere. I've replaced so many of those darn chips on 2141s trying to fix the SSD. And yeah, it never works. It is a total waste of time every single time, and I could have saved so many of these guys if I didn't do that. Okay, I think I found one. Let's just make sure our NAND isn't shorted. If our NAND is shorted, I'm not gonna, on this one board, not gonna put it on, obviously. Shorted NAND is no good. So I should be in the kilo ohms in resistance mode. If I'm at like 500 ohms or less, our NAND is dead and it died from this chip. 12 ohms to ground. Okay, that chip is dead. So we do not want to use that chip. So this is what my life has resorted to. Scavenging donor boards for a single chip. About this one. $428 ohms. I don't trust that either. Okay, this one on the 3v3 circuit on this board. Is this one okay? $500 kilo ohms. I think we have a winner. Let's make sure the substrate is in good shape with no sign of short circuiting. But overall, I think that's okay. I think that looks good. Just debris from around it when I heated it. Got washed under. And what's our orientation? What even board is this? This is a 1987. Okay. Schematics. Folders. Where are you here? It'd help if I could see my screen. I hope this goes into place right. It's kind of crooked. That's on. Okay. Well, this is the main circuit I'm worried about. There's not too much flux around here. It's mainly just this area. And nothing in this area is going to cause death of the board if it doesn't work. It's just not going to turn on. So I'm going to apply power. I want to make sure we have good 2v5 voltages just because I'm dying to know. I'm not going to connect to the screen yet because asking for backlight in post with this much flux on the board is really asking for a lot. So we're going to clean our connector out here with acetone to get all this flux out. And then I'm going to plug a connector in, a USB-C board in. That's in. Okay, and now I'm going to plug it in. And I mean, if this circuit is screwed up, we're not going to get normal booting current, so let's hope. Let's hope. You guys are going to watch that, and I am going to check our 2v5 voltages. And that's not good. Come on. Yes, that is good. That is very good. That is booting current. 2v5 voltage is 2.52 volts. We are good to go. Alright, so this one is good. I'm not, like I said, asking for backlight is a lot. That board is full of flux. So we are going to ultrasonic this, and then we're going to move on to our next case in the meantime. So I'm going to put this back on overhead just so you can see me taking off the heatsink. Not that anybody cares. I'm going to clean this up. I see a lot of people in the groups that will look at a board and be like, oh, look at all this thermal paste over this heatsink. This is fine, just so you know. A lot of people will complain about this covering the whole die or the whole package. That's fine. There's no problem with that. Not a single problem. Other than the fact that this paste Apple uses, well, it's Shinitsu Micro C X83, X23, something or other. It's designed to dry out very, very fast, and it does a decent job for the most part, but I've seen it where if heavy use devices, it doesn't really get a chance to cure, and it just, when it's still on liquid state, it still pumps out. Once it cures properly, it's fine, but if it does not get that time to cure properly, and it just is automatically introduced to high heat, it will pump out. Alright, that is ready. Let's grab another case to work on. What should we do next? Let's clean this work area up a little bit. I think that board is going to turn out just fine out of the cleaner. We'll see. Actually, I'll dry that out before moving on to our next case. I'll just see. I'll get our next case ready, and then after that's dried off, because I'm going to dry it off under here, we'll take care of that next case after that. If anyone's wondering what I'm using to clean my bench, it is this disinfectant called CP64. You can get it online. It's very powerful stuff mixed with distilled water. Like 1 ounce of CP64 to 32 ounces of water, which is actually a really strong mixture, but it does the job. Okay, our next case is going to be a data recovery from another repair store. It is a 1989 that does not turn on. Sounds good to me. I've been working on one of these bully boards, those CD3217s. Yeah, they're a pain. I don't like them at all. How can you stand the acetone smell? Acetone never really bothered me. I'm not sensitive to the smell of acetone at all. It does not bother me one bit. The only thing that bothers me is flux on my hands. That's the only thing that bothers me. Just wiping down our next case with alcohol because it is disgustingly dirty, and I don't want to touch something that is not disinfected. Flip our board, and let's check on this other machine that I had here. So this machine was weird. It's a 2015 A1502, not A1398. And that particular machine was randomly crashing. Now, this is unlike, I've never seen this before, and I did not even know it was possible for this to happen, but it was a 2015 A1398 randomly crashing. It would sometimes black screen only when there's no load. Now, normally that is MOSFETs. So it was no load crashing. I put it under load. It ran for hours under load. Took it off of load. It would just freeze black screen, right? MOSFETs, usually. Replace the MOSFETs, same thing. Then it started kernel panicking. It would kernel panic on boot sometimes. It would kernel panic just randomly in the OS. And the kernel panic was for an SMC process called Don't Steal macOS. Now, if you've built Hackintoshes, you know what this is. Well, replace the SMC. It's been working fine. So it was actually a Apple rework board. So the customer brought the machine to Apple. They reworked the board. Well, they gave them a new board that was reworked by their facility in Texas. And what I saw was like that yellowing of all the components around the SMC. There were some solder blobs under the edge bonding on the SMC, and they did rework by it, and they did not remove the edge bonding around the SMC, or they overheated it. But anyway, new SMC crystal, and that is back to business with no issues whatsoever. So that was an interesting one, and I'm glad to have fixed that. But I've never quite seen an SMC cause random crashing like that. I really wonder if it would have worked just fine with a reball or a new crystal alone, but yeah, I'd rather just replace it. And also, I used a SMC from an A2000426 on a 00163. And it worked just fine, so. Okay. Switch back to overhead. There's our heatsink here. We have about 1 minute left on ultrasonic, and then we can spray it down. The main thing you want to do is you want to remove all the impurities that are in the ultrasonic water. So I'm going to use isopropyl first, then distilled water. They call it rework, we call it butchery. Yeah, that is right. I've never seen quality rework out of Apple's repair facility. It's always bad. This ultrasonic water is bubbly. It should not be bubbly. I don't know why it's bubbly like that. That's very strange. Very, very strange indeed. Anyway, let's spray it down with some alcohol. Help clean some of those in. Then we are going to spray it with clean water. Now, I used to use just a bin of water, isopropyl, but I think this is better to spray it down because you use less and you kind of hose the board down a little bit, and it's a little bit better, in my opinion. There, and now with the board cleaned off, we can dry it off with our hot air. So I'm going to use the backside first, and we're just going to heat it. Good morning from Germany. Good morning, good evening from wherever I am, California. It's kind of scary that I just forgot where I was for a minute. Anel asks, are you still streaming? Yes, I am, and you're not welcome. See your way out. I am not reflowing the logic board. I am drying the water off of the logic board with my hot air gun. Tell us, how the heck did you manage to get a demod? Anel has done many things worthy of more than a demod, so yeah. Caleb's ex-girlfriend demodded me, says Anel. I don't think she's ever had access to this YouTube channel, Anel, so stop blaming other people for your own actions. Okay. Let's look. So here's our reworked area. Looks pretty decent. Those probe points don't concern me. They just look like probe points, nothing else. This area looks good. No concerns there. No concerns here. No concerns here. Alright, it's good to go to the oven. It's going to get baked, and then it'll be ready. Okay, next case. Let me grab it. So we have an A2289 that does not turn on. Let me pull up case details so I can tell you more about what the deal is with this. Let me open a new tab and scan this barcode so I know what we're even doing here. It's no fun not knowing what you're doing. A1989, no power. No power. Okay. So we have 5 volts, 0.25, nothing else. Okay, 20 volts, 0.05, 0.40, 44, 53, 49, 96, 75, 69. Okay, this very much seems like it is charging. So in this case, let's see. Let's unplug. This does not seem fun. This does not seem fun. And now if you were here, you would see why I did not want to leave the board plugged in for long until it had an ultrasonic cleaning, but you're not here. You're just making noise to complain about free content, so you wouldn't know. Okay, it's very dusty, but it doesn't, oh boy, I think I see it. This does not look good, if this is the case. This may be not even a case of taking the board out, honestly. For some reason, my microscope is more irritating than usual. Nope, such just dust. Okay. So let's see what we're actually doing here. This could actually be a case of simple DFU as well. So I'm going to unplug the battery, see what we get. Yeah, 20 volts, 03. That could be... That's so non-specific, that could be anything. That's my least favorite problem to solve, is this 20 volts, 0.03, 0.02. First things first, let's see if it's in DFU or recovery mode. So I am going to plug this into... Now, if you could see, I tried prying that with my hands first, and it didn't work. Prying it with your hands only works if it's never been opened before. I mean, if it has been opened before. I'm gonna sneeze. Microphone fell off. Okay, so just connected this or anything like that. This is something on this particular board. This is a 2018 MacBook Pro. Okay, I just got fan spin. Our fan just spun. Our fan just spun. That's very, very weird. So our fan just spun. Wait a second. This said it's a 2289? This is not a 2289, I don't think. Weird. Alright, so the fact that I'm getting fan spin rules out our T2 or our NANDs. That is very, very weird. That's more leaning towards the CPU side of things. But I don't know. We're going to pull this board. We're going to figure it out. No vCore. No system agent. No VCCIO. Interesting. Okay. I'll take it. The fact the fan spun gave me hope. That seems more like it's going to be a random corrosion type thing than a dead NAND. It is a weird 2289 NL. I totally agree. And someone is asking me via contact form to commit a crime. A 1989. I read it wrong. And I'm not going to commit a crime by selling schematics. Sorry. Cracked PCH. It is not a cracked PCH. I think it's the other way around now. Caleb, I think Anel did a favor for you. Replace it with a pipe and you're good. If anyone wants both of mine, you're welcome to take them. Just weld the pipe in place of the catalytic converters for me. Right out of the headers. And then we're good. It would be so loud. Yeah, it probably really would be loud, I think. It's already loud enough. I don't. The reason why I don't like this particular fault, the 20 volts 0.0 whatever, is the fact that it could be anything. It could be T2 related, it could be NAND related, it could be CPU related, it could be anything. So given the fact this board is so dusty and yucky, I'm hoping we're going to find something corroded. That would be good. The best part of repairing a MacBook is not taking it apart. I know, you're crazy. Caleb, you got scammed off Facebook. You're probably going to get scammed off YouTube as well. I think there's 1502 boards here, so you could just take one. If there's one here, you're welcome to it, if it works. Okay. Let's go to microscope. There we go. And let's have a look. So we have partial fan spin. We have heavy dust. Yeah, this really could be almost anything with this board. That's really, really disappointing. It's dusty, but it's not terribly dusty. I mean, well, it's really dusty, but it's not corroded or anything like that. So, really, when you get something like this, you can't really do much other than thermal image it, so I'm going to do that now. Okay, so thermal imaging, let me get this set up. And if it does not, we are going to force it into DFU and try and revive it. If it doesn't work, since this is data recovery, we have another method we can use and be good. And this is not going to work because... Oh, yes, it will. Look at that. Look at our little thermal. Look at our beautiful little thermal. Hang on, I had something better. Hang on, I could fix this. You ruined the screen on an iMac, Caleb. How did you do that? Explain to chat your shame. I just found a funny email. Oh man. This is funny. Okay, I gotta share. I probably shouldn't share this with everybody. Yeah, this is not. This is. This is, yeah. Okay, back to what I was trying to find. I probably sound like a babbling idiot. Anyway, what I'm trying to find is this filter file for OBS. But I don't know where it went. Anyway, we'll just go with the black and white. That's fine for now. It is what it is. I found a funny email, that's all. I found a funny email of somebody complaining. Okay, I found a funny email of a competing shop trying to make me look bad, and it made them look like a total idiot doing so. That's all. On YouTube, on Google, and I know exactly which shop this was, because the only person that would have a fake customer trying to promote another business would be that shop. And yeah, it was hilariously funny. Alright, we got some cycling going on. Huh. That's just shininess. Alright, we're pulling 310 milliamps right now. Yeah, so anyway, this customer, well, not this customer. First I started getting messages on Google. Then it was questions on Google. And then it was like, okay, so now we are getting, alright, now it's posting. This board posts and works now. Imagine that. Okay, we have CPU V-core. But our heatsink is totally cold. Huh. Now we just lost it. No. Very weird. Hello from Romania. Alright, so this board is very, very strange. The fact is it's partially working, but the CPU is cold and it's not using much amperage, which tells me this might be brain dead. And brain dead boards are no fun to work on because they're almost always in these newer ones dead CPUs. Anything odd getting hot? No. Okay. So this board is, let's dust it off. Most likely this is just going to need to get its data transferred, then that's it. I can't really share how that is done, unfortunately, on a board that does not turn on, but we have a little method, and yeah, for legal reasons I cannot share it. Just gonna dust it off. Alright, let's look again, see if there's anything corroded. I'm mostly interested now. Core circuit? Yeah, it's clean now. It's very, very clean. Alright, I think you just submitted to illegally recovering data. No, there's nothing illegal about that. There's nothing illegal about having a proprietary method. Ask drive savers. There's absolutely nothing. I mean, okay, at the end of the day, I share with you guys as much as I can on how to fix this stuff, but at the end of the day, I still need to stay in business myself as well. So, yeah, if someone wants to get mad about that, so be it. I don't care. So let's see what this does now that it's been dusted off, because corrosion or dust can cause issues like that. The amperage was weird though. It makes me think something's wrong with the CPU, honestly. So let's hope not. Alright, now it's back to its normal not turning on type deal. I really don't think the PCH is cracked, Christian. It wouldn't present this way. Usually it would present... I mean, I could check, but I wouldn't expect to find anything. Alright, we'll force a DFU revive, and then that's it. We're done. Moving on. That's all I can do for this. I went down this rabbit hole and wasted my time with this fault so many times. The fact that, okay, here's why I know it's not a cracked PCH. We had post at one point in time. The fact that CPU vCore was 0.65 is telling us that the board is posting, basically. And if we had a cracked PCH, that would not happen. Anel, there is a business for sale that you may be interested in. It's a good opportunity for you. Okay, I don't even want to know what a store owned and operated by Anel would look like. I feel like it would be a disaster. It would be a legal disaster. None of the paperwork or taxes or business licensing would be done properly. It would be a dysfunctional disaster of a repair store. That would probably be in business for a month before getting shut down for some criminal activity of some kind. So I don't think Anel is cut out to be a business owner either. Okay, let's DFU. Force this into DFU. You guys can't see this, obviously, but, well, it's not that I don't want to show you this. It's on the Mac Mini, and I am on a Windows PC. I will launder money constantly, says Anel. Yeah, you probably would. That's why. You would end up in... It would be a month or so before you were in jail for criminal activity of some kind. I don't know what kind of criminal activity, but there would be some shady stuff going on that you'd get thrown in jail for after a month. Okay, DFU. Force DFU. Let's do it. Would I bail you out of jail is what you're asking. No. I would not. You have enough money, you could bail yourself out of jail. Alright, it went into DFU right away instantly. That's a good sign. Okay, so if this completes DFU, if it revives with no problem, then we're good. So, I mean, if it revives with no problem, then that means so it says installing system. Now, if it gives me an error, if it says, failure to revive or whatever, that usually means it is something with the T2 or the NAND that is not good. In that case, that does not fare well for data recovery. Installing system. Waiting. Fortunately, this is just a waiting game. We just have to wait and see if it'll resolve. I would expect at this point for the fans to be spinning if it was going to work. So it's all down to what this tells me. If it says, if it revives and gives me the lock icon, we're good to go. Well, we're not good to go. It means the T2 and the NANDs are fine. If it doesn't, that means that one or the other is probably, emphasis on probably, bad. Still waiting. My guess is it will revive normally. That's what I'm putting my money on, but because there's something else wrong. In the meantime, I'm going to go get us another case picked out. So I'll be right back while I do that. And we will let this revive and see what happens. Alright, it is still on installing system, so we're just going to let that go. In the meantime, we're going to take a look at this A2289 that does not work. Not A2289, A1990. So we're just going to let this thing do its thing. We'll come back to it, but we're going to look at this 1990. Let me get these screws taken care of. Most likely this is just going to be a data transfer. Yeah, not the 1990, the other one we just spoke about. Okay, here we go. System cannot be restored on this device. Booted of device state booted OS expected DFU, probably caused by a transient USB layer. Probably caused by a transient USB layer issue causing missing or duplicate events. Okay, so that tells us that either a CD32, 15, or 17, or the T2 USB controller issue. The USB controller portion of the T2 is having issues, and I've seen that before, and it was not the CD3215s. So, yeah. That, I would put my money on. That is a dead T2. There's something wrong with the T2. At least that gives us a code, you know, somewhat of a something we could work with and know. Hey, Paul. Paul, I just had a board, just like the one you messaged me about. It would get to 300 milliamps. Oh boy, I'd regret opening this. This smells like piss. What I'll do is measure the nans. Let's see. What are the nans? I'm not even going to waste my time if the nans are... Are you using the right screwdriver for that? Doesn't look like an Apple authorized one. Yeah, it's Apple authorized. I'm sure. It comes with the batteries that say they're genuine on eBay. It has to be Apple authorized. Okay, what are we? 176 ohms. That gives me shudders because that could be both ways. Let's see if I get 2v5 voltage. 177. This is bad to even be plugging this in. Just that gives me chills down my spine because it's not definitive. If it's 2k ohms, I know it's alive. If it's not 2k ohms, then... Oops, I just measured resistance with the board on. 5 volts, 0.04. Well, what is our PP bus voltage? 0. Okay, so PP bus is shorted, probably through the regulator. Let's see. Maybe. Yeah, PP bus is shorted. Okay. It is a no 01841. I think one of those. I need a magnet. Okay, so Paul, I did not fix it. What it would do, it would randomly turn on, or it would randomly get fan spin, no post. And I did DFU revive, and the error it gave in DFU revive was Unexpected device state, booted OS, expected DFU, probably caused by a transient USB layer issue causing missing or duplicate events. And how I interpret that is most likely the USB portion controller of the T2 is having issues. I've had one of these before where I went through, replaced all the CD3215s, same thing. So, yeah, that's... But yours did complete a revive, so it would be a little bit different maybe. I don't like this board. It has a very strange texture to it. I want to wipe my hands off with a Lysol wipe and put gloves on. It has a very strange, just not... I think I'm touching some kind of a bodily fluid in this device, so I don't want to take chances with that. It could very well be, Paul. This, yeah. This does not sound like something that's going to end up being fixable. At least on mine. I just need to get data, so I can still most likely do that, but anything else I can't. Okay, now I have gloves on. This is much better. I don't want to get monkeypox. Almost done. I hate disassembly. It really is not fun. I really dislike it. Alright, I need to get a little container for these screws. Let me just pull this board out and see what we're dealing with on the other side. Oh man, this is a mess. I almost want to ultrasonic this first. Um, I need water. I'm gonna go grab water. All right. Okay. So PP best short. Let's do it. All right. So let's find this PP best short. First off, just jump right into thermal. I'm gonna use really low voltage. I'll use 1.3 volts. That's low enough not to damage anything. This mat is disgusting. Hang on. I don't know how people can go without cleaning their work mat after almost every job. It's just this dirtiness bothers me. And I know everyone is probably watching this saying, oh, you're just crazy. That mat is perfectly clean. Well, it doesn't feel clean. It feels dirty. It feels really yucky. So I don't like that. I want to clean it. It's like sandy. I don't want a sandy MacBook or sandy work mat. I want a clean sanitary work mat. Alright, here we go. So I see many potential causes for short to ground. We just got to narrow it down. And let's see. Alright, I pull 1.3 amps. That's plenty to find a short. Let's grab our thermal. And it doesn't want to work. There it goes. And it's probably going to be our NAND regulator, and that means this is dead. If it is the case. Yep, as I suspected. So, here's the deal. The chances of this surviving, well, maybe it's a capacitor. Let's zoom way in high def, and let's see. Can actually see what gets hot. That's a tough one. I think it's the capacitor. Because the trace gets so hot and it sinks in, it just gets pulled into that chip. That's tough. That cap is indeed on PP bus, but the problem is I'm gonna up it to 2.5 volts, 2.3 volts. Let's see what happens. All right, that is definitely the capacitor. That's not the chip. Okay. This whole area looks really bad though, so we'll see what we get. The fact that that rail is 1.76 ohms, not 176 ohms. That doesn't sound good. Sorry if I'm not making sense. I am tired. I am at work, and it is almost midnight, and I'm still fixing MacBooks. But I find the same thing, Paul, and it is very concerning to me. But when we see this, oh, that did eat through the board. Look at that. You are totally right, Paul. Look at that. Hang on 1 second here. This is most likely going to be dead. Just a second. look and see what we have here. Okay. So our capacitor in question is going to be this guy right up here. Around the via, there's a little bit of hypodensity. Hypodensity meaning less dense, which means usually carbonized PCB right there. It's hard to say how deep it is. That looks maybe like it's down to the third layer. And you can see a little bit of the trace melted right there, a little solder ball right on that trace. Right there, for sure, there's some hypodensity. Won't really know until we get into it. But this one, it looks pretty widespread. Right there, you can see that darkness right there, and that's most likely going to be pretty extensive, unfortunately. Alright, let's get into this. I don't know what we're going to find. Did not want that, but let's jump right in. Not very promising, not what I was hoping to see on those images, but is what it is. I would say it's down to the third layer. That's around those vias, that's that hypodensity you saw right there. Let's just jump right into this. This is going to be deep. Could already tell this is going to be deep and miserable. Yep. Oh yeah, this is toast. Look at that, it's so extensive. Look at that, there's no saving this. That may even be deeper than third layer. That's super, super deep and super extensive. Let's just see how far it goes. But that's what we saw, that dark area that was a little bit exaggerated on X-ray. That's what this is right here. It's pretty extensive. Yeah, we're not getting data from this. I just want to clear it so it's not a blatant fire hazard. But yeah, there's no... Yeah. What do you think, Paul? You think we're going to get data from this? Do you think there's a chance, or just call it? Because I would just call it. I don't think there's a chance, but it's always good getting a second opinion from someone that's smart. Where's my little syringe for acetone? Did it disappear? Seems it did disappear. Whatever, I'll use this one. This is almost through the entire board. And there's some data traces that I'm just seeing too right there. It's under the reg. It is so extensive. It extends deep under the regulator. It's still going, and I'm almost through it. It's still going. It's still going. There, it's cleared finally right there. Through those vias. Okay, let's give myself a little more room. Once I clear this all, I'll measure my resistance again on 2V5 on the NAND side and see what it's at. And then we make a determination if we continue. But if the NANDs are dead, then we don't. Simple as that. Yeah, I don't really want to have you ever transplanted a T2? Swap, which one? I think I've done a couple. Probably not, because it's kind of a useless task, honestly. You can't get good CPUs, and yeah. It's just not, it's a pain to do, and so probably not. The thing is, no one really wants to pay for CPU replacement, so. And it's only for data recovery purposes. It doesn't last long. Even if you're really careful with heat, it doesn't last long. So, no. This is extensive. This is like the board equivalent to cancer. You gotta cut all that black stuff out, and if you don't, you're gonna have problems. And I'll take another image after this, and we'll look and see if there's any remainders at the margins that we did not get, and as well as look at any traces that we may have impacted during this. This, I'm pretty sure, how many layers is this? 1, 2, 3, 4, 13, 14 layers or so. So yeah, my prediction of the third layer was very far off. No, we're through the board. Yeah, we're totally through the board. Look at that. We're totally through the board. It's alright, I can clean it from this side too. I want to get this post off of here. There. Alright, now I can cut this side as well. Clear out the hard to get side. Let me clean this area up. I need to clean this up. So if I remove this and our resistance on our 2v5 lines, CPU swap is at least $1,000, if not more. So if I can clear all this up and our 2v5 lines are in the kilo ohms, I'm going to go back, not tonight, but we'll rebuild all this and get this working again. And no, this is not cheap. This is very, very expensive. I get people that'll email me, oh, I'm looking for help. I'm hoping you could help me for under $80 or this and that. No, sorry. This is really, really bad. There's no knowing where these two traces went. That's my main concern out of all of this, is those two traces and where they went. I doubt they just went straight across. They might have right here. Let me clear this first layer off so it's easier on me. This seems barbaric in nature, and it absolutely is, but this is the only way to do this. I like the number 11s better, honestly. I just grabbed the curved because it was sharper than this one. It was right there. I need to order more. I'm pretty much out of good blades. There's another data trace that I just saw. Yeah. See that right there? It goes under the NAND, where the NAND is. Just clear this one last area out. I'll take another image and we'll see how we look, but this is not good. I just want to clear out as much of this so I don't get a false reading on our 2v5. You know what? You know what I'm going to do? This is extreme, but I need to cut out all of this junk. I need to use a drill. This, yeah, it's so extensive into the layers in that area. I need to take out that whole corner chunk of the PCB. And then we could work on what traces and what's what later, but this, I need to get an actual area that I can work with, because it just keeps going deeper and deeper and deeper, and I don't want to get a false short when it's still in the PCB and not the NAND. So we'll clean out all of this, then we'll worry about what we have as far as traces later on. We could figure that out, but we need to clear out this internal short as much as we can. So we're going to use a dental bit. We're going to clear this out. Might get a little loud, so if you're using headphones, then I recommend mute for a second here. You've been warned. We have two more traces right here. So I want to kind of trace those around and see where they lead to. It's rotary, Paul. Yeah, it's definitely a rotary, and it's this little tiny small dental bit. Okay, so I've located our traces that we cut. So that's good news. I know there's 3 that we need to run. There's technically, I gotta clean this alcohol up real fast. But I've located our traces. I've located the 2 traces. Now the moment of truth here is we gotta clean this up a little bit more with our X-Acto knife just to make sure there's no burrs touching. And then we see if our NAND resistance is normal. And if it's not normal, then this is trash. If it is normal, then this is a several month-long project to get this person's data. Okay, so yeah, so these 2 guys go over here. I'm almost certain of it. And actually, this looks pretty good. Let me see. What's our PP bus? Alright, our PP bus is now in the kilo ohms. Mega ohms. So that's good. And guess what? Our 2v5 NAND is actually in the mega ohms. So this yes, Nisacat, this is for a data recovery company, and they will most definitely pay for the data. What about all our Ocarina lines? 122, 123, and 4. This NAND is okay. What we did here, it may have saved this. So I may be able to dead bug this chip and save this board. This is a long, big project, and I think this is great that I'll do a video on it. This is not a project to do tonight. This is going to be a long project, but there is a chance that this person's data will be back after this. So we went from having 176 ohms on 176 ohms on 2v5 to having mega ohms. Same with PP bus. There's still a chance that we may have an issue. Wow, my FPS is really slow. It doesn't seem right. But there's a chance this person's data could be saved. So this one, we're going to call this one for now. And we're going to get back. I think I'm actually going to call it a night. I still need to pack some stuff for shipping. But I think it's been a good run. And I think we're good. Actually, no. We need with the first board that we worked on, we need to see if that works, and then we'll call it a night. That'll be a good end for the evening. Thermal camera's all tangled up here. Got to get the thermal camera out of here. And then the drill also out of here. I gotta clean all this alcohol up on my bench real fast, so bear with me. It's soaked. Okay. Just clean my heatsink off real fast, because we gotta put a heatsink back on that board. Hopefully it's all dry. I think it will be. I think we will be good to go. But let me just turn it on real fast and make sure that it is dry, rather than assembling the whole device and having to take it apart again. Okay. So this initially had flickering backlight, but the corrosion was pretty in-depth, but let's make sure it turns on. So I would expect 20 volts and a hot CPU in a second here. And yeah, the CPU is pretty hot. I think it just thermal tripped too. So I think we're good. Okay, thermal paste. Got a coarse shell. This is my thermal paste that I'm going to be using. It's good stuff. It works really well. We're going to be releasing some very promising data soon. That really surprised me as well. Even though I created it, it works really, really good. So, put a big glob amount. This is going to trigger so many people. That's why I'm showing it. Alright, let me grab the enclosure. Shut this off. Let me put back on my overhead. And this is our enclosure here, right? Yep. Okay. Pretty clean device. Let me just check and make sure our ports look okay. This could use a little cleaning. Little cleaning and it's good to go. Okay, let's hope for a nice image, full backlight. Working keyboard. Working touch bar. Everything. We want everything to work. Come on. Oops. Put this little clip back on in a minute. Alright, let's see if this works. Keys are a little sticky. Fan just spun. Apple logo. And customer name. No. Yeah, I don't think you'll be able to see the customer name through that. Oh wait, I didn't plug the battery in. It's not going to boot without the battery. Okay. Yeah, you're going to complain about no battery. I understand. You don't want to be a MacBook, I don't blame you. Come on, give me a progress bar. I don't want to show the customer's info, so we'll just give it. We have a cursor. Probably started in recovery. Yep, look at that. It started in recovery mode. Which is honestly good because I can test the keyboard real fast. Alright, even the sticky keys work. So we're good. Yeah, so this basically proves it's working. I mean, everything seems good to go. Let's just restart it, get it into the OS. Again, now I really gotta cover it. But this looks like a win. That's a win. It won't work until it's in the OS, but everything seems to be working good. Keyboard works. This one's a win. At least I can call this one tonight. So thank you guys for watching. Really appreciate it. And I'll see you in the next video. We got some interesting stuff to go over soon. We're going to be doing a formal video for our LumaChill thermal compound. We got a lot of stuff, exciting stuff coming from that. I can't say too much about our testing results yet, but they were very, very, very impressive when compared to many other people's very famous pastes, including but not limited to Noctua and TH1, Arctic Silver 5, and Arctic MX5. It performed very, very well compared to those. So we'll be releasing a video on that soon. That'll be exciting. Right now we're scaling up production. Before we do that, we have hundreds and hundreds of bulk orders right now. Well, not hundreds, hundreds of tubes to fill for other companies first, and then we'll make an announcement there. And once we have enough stock on our end to support, in case there is a lot of purchasing of it, but it's gonna go well. But that's it for tonight. I'll see you in the next stream.